Section 3.3 teaches another way of solving our linear systems of equations. And before we can learn that way, we have to talk a little bit about matrices. Matrices are basically an ordered set of numbers. Like, for instance, this matrix over here is a system of numbers. And you always name a matrix by the number of rows that it has, by the number of columns. So if I called this matrix A, the dimensions of it would be a 3 by 2 matrix. 3 rows, 2 columns. This matrix, if we call this matrix B, the dimensions of this would be a 2 by 3. 2 rows, 3 columns. We are going to have an entire chapter on matrices, but they have to introduce them to you a little bit to show you the next way of how to solve systems of equations. In order to do this solving, we have to talk about a determinant. A determinant is a mathematical number representing a matrix. Now, if you look back at the matrix before this, you notice when it just presents the matrix, it has, like, if you will, shoulders and feet on those lines. But when it wants you to find the determinant of a matrix, it basically just has parallel lines that look a lot like absolute value bars. To find the determinant of a matrix, what we do is we multiply up, so 6 times 3 is 18, minus 2 times 5, which is 10. Then I subtract that, and I get the determinant of that matrix is an 8. If I do this one, you always multiply up, so 8 times negative 2 is negative 16, and 5 times 7 is 35, and I'm going to subtract, so that's going to give me a negative 51. So that's the determinant of that matrix. Again, multiply up, so that's going to give me a 15. 3 times 5, and then 2 times 4 is 8, so 15 minus 8 gives you a 7. So that's how you find a determinant of a matrix. We're going to take that and we're going to use it using something called Cramers Rule to solve a system of equations. This is the pattern of Cramers Rule, and I don't ever memorize the actual letters, if you will, but if I have an equation that's set up like this, ax plus by equals e and cx plus dy equals f, then on the bottom of my x I have, if you will, that coefficient and that coefficient, a over c, b over d. And on the top, it's like I'm reading in North Africa, and I'm going to go ef and BD. Now this is going to make a whole lot more sense when we do one. The bottom of the y is the determinant of the same thing, A, C, and B, D, but the top now is the first and the last. So the bottom is first and second, if you're looking at the columns here, first and second, and then the top of the x is last and middle. The top of the y is first and last. So let's do one so this makes more sense. All right, so if I'm going to set this up, the bottom of my x is going to be this determinant. I'm going to go 2, 1, negative 3, and 5. And that literally is going to be the bottom of both my x and my y. So 2, 1, negative 3, 5. And my top, remember, is going to be my last. For my x, it's last, which is 9, negative 2, and then negative 3, 5. So it's last and then middle. So to find the determinant, I multiply up, which is 10. Multiply up, which is negative 3. So I have a 10 minus a negative 3. So I'm going to have a 13 on the bottom there. Multiply up, Let me pull it down a little bit so you can see it. Multiply up is going to give me a 45. Multiply up is going to give me a 6. So I have 45 minus 6, which is going to give me a 39. And if I divide 39 by 13, I'm going to get an x value of 3. Now over here, I've got the y already set. I already know if I did the y correct here, or the bottom correct here on the x, then the bottom of the y is also 13, which if you did that determinant, that's what you would get. Now remember, the top is first and last. So it's the determinant of 2, 1, 9, and negative 2. Okay, so I multiply up, I get negative 4. Multiply up, and I get 9. So I'm going to get negative 4 minus 9, which is a negative 13. So my y value is going to be negative 1. So those two are, if I had graphed them, they would have crossed at 3, negative 1. If I had used substitution, I would have figured out that x is 3, y is negative 1. If I had done elimination, I would have figured out that x is 3 and y is negative 1. So the solution to that system of equations is 3, negative 1. So let's do this one down here. I know that this is kind of weird, okay? So applying Cramer's rule to this one, if I set it up, I have x is equal to, the bottom, remember, is this and this, this and this. So I have 6, 1, 7, negative 1. You're just using the coefficients. What you have on the bottom of the x is the same thing that you have on the bottom of the y. On the top, I have last, which is negative 9 and 5, and middle, which is 7 and negative 1. So the determinant of the bottom is going to be negative 6 minus 7, so I'm going to have a negative 13 on the bottom on that. On the top, I'm going to have a 9, and I'm going to have a 35, so I have 9 minus 35, which is going to give me a 24. I believe that's right, if I've done that right. 9, 5, 7, negative 1. Okay, so that's going to give me, actually it's going to give me a 26, a negative 26. Okay, so that's going to give me a value of a positive 2. And then over here, again, if I did it right here, I know that I have negative 13 on the bottom there. And I'm going to have first and last. So 6 over 1 and negative 9 over 5. I find the determinant, so I have 30 minus a negative 9. So I have 39 on the top, which is going to give me a negative 3 on the bottom. So my ordered pair, or the solution to this, is 2, negative 3. All right, your homework for this is on page 144 through 145, 14 through 32 even.